just multi-port network. And today's emphasis is the indefinite admittance matrix. Now you can recording this course. Everybody can recording, and I'm recording also. Then I will share the PowerPoint. Okay, we have defined the definition of the IAM, indefinite admittance matrix. We choose an external point as reference. Choose external node as reference. Then we got the YIUN equal to IN. The NUN is node voltage. There will be total N node voltage. And this is a basic definition of the YI. How to find the YI? We can get the YI from this definition. But this method is similar to the multi-port network YSC calculation, but it's very complicated. We always don't use this method. We will introduce a simple method soon. The calculus of the IAM. Every column sum together will be 0, and every row sum together will be 0. This is the most important calculus of the IAM. Today, the emphasis is the usage of the IAM. Why we discuss IAM? Because we can use the indefinite admittance matrix to use for the connection of any kind of network. We introduce 5 kinds of connection. At first, the terminal connect to ground or float. If connect to ground key equal to, this is IAM. We have 3 nodes, and we choose this node, the external node, as reference. This is reference. So for the IAM, UYI UN equal to II. This will be 3 variable, 3 multiple 3. It will be like this. This is YI. Point 1, node 2, node 3, node 1, node 2, node 3. If we connect terminal key to ground, it's equal to use the node key as reference. We can just remove the row key and the column key from YI. If we connect the node 3 to ground, connect them together to ground like this. So for the indefinite admittance matrix, now it changed to this IAM. This will be definite admittance matrix. This is DIM. So from the YI to YSC, it will be easy. Just delete this column, this row, this column, because we choose node 3 as reference. If we choose node 2 as reference, so we can just delete this row 2, column 2. So you can choose any point, any node as reference. So this should be the definite admittance matrix. Is also YN. But why we use YSC to express? Why use SC? The YSC means the 2-port network. Pay attention to this problem. The node 3 is reference. Node 3. This is node 1. This is node 2. So node 3 is reference. We can treat 1 and 3. And 2 and 3 as a port. 1 and 3 is also port. So this is port 1. This is port 2. So this YN is also YSC. This node voltage is a port voltage. This node voltage is port voltage. Because node 3 is a common point. So pay attention for the SC express. If terminal float, so that means this is a definite admittance matrix. This is definite. If we float the node 3, this is YSC, definite admittance matrix. is also yn by n. So it's a 2 multiple 2. This is the reference. But for this node, this network is indefinite at the meter matrix. We should add the node 3. Node 3. So row 3, column 3. How to add this component? When we add this row and this column, we use the zero-sum character. Zero-sum character. So that means when we add this component, we should make this column 0. Add together 0, add together 0, add together 0, 0. And then add this component. Add this row equal to 0. Add this row equal to 0. And then this position, okay. Then we can go to this position. Add this row 0, or add this column 0, add this row also 0, 0, also 0. So we use a zero-sum character to add the node 3, the row 3 and the column 3. For example, we have a passive 3-terminal network N. Connect terminal 3 to ground. This 3. Short connect terminal 2. This terminal 2. And add unit impulse voltage to the terminal 1. This is terminal 1. And add impulse voltage source delta T to terminal 1. And then terminal 1 and terminal 2 current. This current I1 T. This I2 T will be this form. If we should connect terminal 1, add a unit step voltage source to terminal 2, that means the terminal 3 connect to ground. Should connect terminal 1 is 1. And terminal 2 add a unit step voltage source. Then we can go to the I1, IT again, I2 again. These two solutions. Find what? Find the terminal 2 as a common point. When the 2 are the common point, this is point 2, this is point 3, this is point 1. Add 2 ohm to terminal 3 and terminal 2. So that means this point are 2 ohm. And add the unit step voltage source to terminal 1. T. And then try to find the terminal 1 and the terminal 3 current. This I1 and this I3. This node 2 as reference. So this is a question. The first 3 is node 3 is a reference. Node 3 reference give you two conditions. Add the source in the left, the response. Add the source in the right, the response. And then ask the node 2, this node 2 as reference. Node 1 and node 3 add the source to the node 1, add the resist to node 3. Try to find the I1 and the I3. Find I1, I3. So for this question is we change the reference. So we can use the yi to calculate. Use y to calculate. At the first, the case 1. Because the right side 2 connect to ground. The one connect to add a delta t. This I1, this I2. We use Laplace transform. The delta t transform is 1. This short connect is 0. So this I1, I2, Laplace transform. So from this function, we can find the y11 and y21. That means I1, I2 equal to U1, U2, Y11, Y12, Y21, Y22. U2 is 0, U1 is 1, equal to 1. So I1, I2 tell you. So Y11, Y21. And then U1 is 0, U2 is 1 over S. Should connect. And 1 or 2. This Epsilon t step function. The Laplace transform is S equal to 1 over S. So the I1, I2 Laplace transform. Then we can calculate the Y12, Y22. So we have got the 6 use time 3 as a reference, the point y parameter. This is point 3 as a reference, y parameter. And then we float the point 3. Then we can go to the 3-terminal network, indefinite admittance matrix. It will be this yi, indefinite. How to add this row and this column? The method is make this row equal to 0, make this row equal to 0, make this column equal to 0, make this column equal to 0, and then make this row equal to 0. So I found this one, and then the last one. So for this network, it's an indefinite admittance matrix. Then we use terminal 2. This is terminal 2 as reference. So how to use terminal 2? Just delete row 2 and column 2. Delete this row 2, column 2. So we can go to the use terminal 2 as reference. So we can go to U1, U3 multiply 2 equal to I1, I3. And now this is node 2, node 3, node 1. And we add a resist, 2 ohm resist between terminal 3 and terminal 2, and add a voltage source. Epsilon t. So the Laplace transform 1 over S. Because this 2 ohm, so the I3, this I3, and this is U3. So U3 equal to 2 mod I3 minus. So this I3 and U3 relation. So we can calculate the I1 and I3 easily. How to calculate? This function, and I3 equal to U1 equal to 1 over S. So 4 variable I1, I3, U1, U3, and 4 function. This 2 function, this function 3, function 4. Then we can calculate the U1, U3, and I1, I3 easily. So calculate I3, I1 very easy. And then use the Laplace inverse transform. From I3, I1, go to the time domain result. The conclusion, from the indefinite to definite admittance matrix, just remove one row and one column. We can got the n-1 point definite admitted matrix is also n-1 port network. What this means? For example, we have a network N. The network N have a total N nodes. N nodes. Node 1, node 2, node P, node n-1, and node N. And now we can treat them as, we can treat node N as divide the node N, this node N, to total N nodes. They should connect. We call this 1 sharp, 2 sharp, 3 sharp, and this n-1 sharp. And then we can treat the 1 and 1 sharp as a port. This is port 1. Port 1. And 2 sharp as port 2. The 2. 3 sharp as port 3. So to n-1 and n-1 sharp as port n-1. So for any n terminal or n nodes network, we can treat it as n-1 port network. Pay attention, this is a very important concept. Any n terminal node or n node network, we can treat it as n-1 port network. We can choose the node n as a reference point. Node 1 and node n as a port. Node 2 and node n as a port. Node P and node n-1 with n as a port. So this is meaning. So we can got n nodes in a definite matrix. DM is also an n-1 port network. If from the definite admitted matrix to indefinite admitted matrix, according to the zero-sum character, add 1 column and 1 row, then we got the float IIM. This method can be used to change the network from one common point to another common point easily, such as the transistor connector COM to the base COM. So this is used to, that means the YD can use to change the reference point easy. So we call this short to ground, and float to ground. Use it to short connect, or we call as a contraction short connect, or several terminals together to form a new terminal. For example, this indefinite admitted matrix. We should connect the 1 and 3, add them together, connect them together. So we got a new node 1 sharp. That means the node 1 and node 3 should connect. So the total current I1 sharp, this I1, this I3. So the I1 sharp will be I1 plus I3. And the U1 sharp 这是 U1 sharp. From this point to the reference, this is U1 sharp. U1 sharp will be the U1 will equal to the U3. So we change this network from 3 nodes to 2 nodes. From 3 nodes to 2 nodes. Then we need to at first add the row 3 to row 1. Add row 3 to row 1. Add this row 3 to row 1. So y11 plus y31, y12 plus y32, y13 plus y33. And then add the column 3 to column 1. So this position will be 4 components. And this position y21 plus y23, y21, y31, y33 are together. And then delete 3 row and 3 column. So only the 1 sharp left, 2, 1 sharp, not 2 left, 2 left. So we got a new indefinite eliminator matrix. It for example, I will draw it here. This is node 2, and this is node 1 sharp. The 1 sharp inside is 1 and 3. Should connect. So there's only 2 nodes left, 1 sharp and 2. The order of this indefinite eliminator matrix reduced from 3 to 2, but it still is indefinite eliminator matrix. That means this row altogether will be 0, this column. This row altogether will be 0 also. Why we add the column 2 with column 1 and the row 2 to row 1? One should connect node 1, node 2. According to the KVL, we should add the U1. The U1, U2 will be equal. Add column 2 to column 1 and then remove column 2. Or add column 1 to column 2, remove column 1. What this means? Because the function, the I1 equal to y11 u1 plus y12 u2 plus y1n un. I2 equal to y21 u1 plus y22 u2 plus y12n un, and so on. U1, U2 will be equal. U1, U2 will be equal. So we write this function, this column, we'll add this column together, add them together. They are equal. Then add them together, and then we can remove the column 2, And then according to the KCL, the total I will equal to I1 plus I2, add them together. So this row will add this row, So I1, I2 to IN, this is the indefinite eliminator matrix. This is the yi equal to yu. Because we should connect node 1, node 2, so the U1 equal to U2. So we can add the y11 with y12 together. So this should connect KVL. Add column 1, column together. And then the total current because node 1, node 2 should connect. This is 2. The node 1 sharp. 1 sharp, I1 sharp will be I1 and I2 added together. So the total I1, I2 will be row 1 plus row 2. Row 1 plus row 2. So this is row 1 plus row 2. And then delete the row 2 and column 2. Then we got the 1 and 2. 1 with 2. Point 1 with point 2. With point 2 should connect new n-1 network indefinite admittance matches. Beta is still indefinite. Just because the two nodes have the same voltage and the current is the sum of the original two nodes. For example, this 4 nodes network. 4 nodes network. So that means one, 2, 3, 4. Should connect node 2 and node 4. Node 2 and node 4. And then we use a 2 sharp to express. 2 sharp express. Then we add the row 4 to row 2 at first. And then add the column 4 to column 2. To column 2. To column 2. Add row 4 to row 2. Add column 4 to column 2. Then we go to this. For this indefinite admittance matrix, this is node 1. This is node 2 sharp. This is node 3. So this is node 1, 2 sharp, node 3. So this is the parallel. This should connect. Open circuit or separation. Open circuit. One or more nodes open. The current change to 0. The node change to an inside point of circuit and have no relation with outside circuit. For example, the 3 node network, this is a reference point. If the I3, if the point 3 will never connect to outside, that means this point opened. So the I3 will be 0. Will be 0. We call this as open circuit. Because it's open circuit, we can treat the network as this network. It's only 2 point node left. This node 3 as an inside point. So the inside means we can treat the node 3 as a network inside point. So only 2 points left. Open circuit nodes can use vector I2, U2 to express. We use 2. This 2 means the nodes need to be opened. And the other nodes left use I1, U1 to express. We can divide the Yi, Ui to 2 parts. I1, I2. I2 means the node 2 be opened. And I1, U1. For this example, this I1 is I1, I2, I3 equal to this is U1, U2, U3. And this part we use I1 to express. This is I2 to express. This I1, this I2, and this U1 vector. This is U3. And for this network, we divide it into 4 parts: Y11, Y12, Y21, Y22. So because this part is open open means this I2 will be 0. I2 equal to 0. So the y21 u1 plus y22 u2 equal to 0. Equal to 0. And from this function, we can get the u2 expression. U2 expression. That means I2 is 0. Then we calculate the U2. This is U2 expression. And this U2 expression we place to the I1 equal to y11 u1 plus y12 u2. Place to this function, we can get the I1 and u1 relation. I1 u1 relation. So for this part is the open k-node indefinite admittance matrix. So it's still indefinite admittance matrix. So this is for the open segment. Open. This is the function to calculate the how to open. The part 2 is the open node. Part 2. This is a change function. If we open only one node, so the y22 inverse will equal to y22. The y22 will be 1 over 1, only one component. 1 multiple 1, only one component. So if open only one node, it will use this function. This will be easy. If open k nodes, use this function. In the practical, if some nodes have no current flow in, we can separation it. Separation will decrease the order of the matrix, but will not change the singularity. So that means after the separation, it's still indefinite admittance matrix. For example, 4-node network. Connect node 4 to ground. Node 1, 4, 2, 4, and 3, 4. 1, 4, 2, 4, 3, 4 form 2 nodes. But we only care about the 1, 4 and 2, 4. We don't care about the node 3. We just keep this port 1. This port 2. We don't care about the port 3. That means the port 3 will not have a source. This I3 will be 0. Then it will be like this. This is node 4. 1, 1 sharp, 2, 2 sharp. So this question is, give you this circuit. Try to find this 2-port network Y parameter. We can use the indefinite admittance Yi to calculate. For this network, how to write the Yi? Pay attention, this is important. Give your network how to write the Yi. It will be simple. Node 1, 2, 3, 4. This is 1, 2, 3, 4. At first, for the diagonal line, every position is the node total admittance altogether. For the node 1 is here, node 1, there's 2 branches altogether. So there will be G1 plus SC1. Node 2 is here. So this branch with this branch. So it's G2 plus SC1. Node 3 is here. This branch. So it's G1 plus G2 plus SC2. And for the node 4 only one branch. So it's SC2. So this diagonal line. For this part, This will be node 2 and node 1. Node 2 and node 1 mutual admittance 2 and 1 2. So this branch minus SC1, it will be negative. This position and this position will be 1 and 3. 1 and 3 mutual admittance. This position and this position will be 1 and 4 mutual admittance. There's no mutual admittance between them, so it's 0, 0. So this position and this position will be 2 and 3. 2 and 3. This position will be 4 and 3. 4 and 3. 4 and 3. And this 2 and 4. 4 and 3 minus SC2. This position and this position will be 2 and 3. 2, 3, so minus G2. So for this part, it's important for you how to write a yi. How to write the yi? We don't use this definition. We don't use this function. This function is very complicated. We don't use it. We can just write the IAM very easily. So this is the method to write the IAM. It's easy. So this is important. This is important. Write the YM. And then remove Y row 4 and column 4. Get the 4-point network definite element match. We choose node 4 as the reference. So remove this row and this column. Get the Y3. Get this point. Use node 4 as reference. So this is node 1, node 2, node 3, node 1, node 2, node 3. And then the node 3 have no current. So with separation, separate the node 3. So we should divide this match to 4 parts. So to 4 parts. Node 3. So this is Y11, Y12, Y21, Y22. And then use the function Y equal to Y11, this matrix minus together and over 1, 2, 2. Use this form. So this will be use node 4 as reference and separation node 3. So that means don't connect out. So the 2-port network Y parameter. 2-port network. This is port 1. This is port 2. Y parameter. So for this question, we write the yi at the first. yi is 4 multiple 4. And then change yi to yd. yd means we use node 4 as reference. So we'll 3 multiple 3. And then separation the node 3. Then we go to the YSC 2 multiple 2 YSC. So this is our method. Okay, let's have a rest. Rest for 10 minutes.